Hello everybody and good morning to all of you. And today I am going to tell you some numericals on length contraction. And this length contraction is under relativity. And in relativity there is two frames. One is S, another is S dash. And S is at rest and S dash is moving with uniform velocity V. And both the frames, in both the frames the x-axis coincides. And the observer is at O is at rest and the observer O dash is moving with the frame S dash. And there is a rod here. And the observer O measures the length of the rod as L0 and the observer O dash measures the length of the rod as L. Okay, and V is the velocity with which the frame S dash is moving along the x-axis. Okay, so L is equal to L0 into root over of 1 minus V square by C square. Okay, so let us do some numericals so that in the entrance examinations it will be very easy for you. Okay. See here, the first question is a rod has a length of 2 meter. That means L0. That means the length of the rod at rest. Here L0 is equal to how much? Here L0 is equal to 2 meter. Find its length when carried in a rocket. That means rocket is moving. So you have to find out length L, not L0. L is the length of the rod while in moving and L0 is the length of the rod while at rest. So while at rest the length is 2 meter. That means L0 is equal to 2 meter. And you have to find out length when carried in a rocket. That means when it is in a moving system. That means you have to find out L. With a speed of 2.7 into 10 to the 6 meter per second. That means the velocity of the rocket is this one. That is V. So here V is equal to 2.7 into 10 to the 6 meter per second. So we know L is equal to, the formula is L0 into 1 minus B square by C square root over. So put the values simply. L0 is equal to 2 into 1 minus V square. It is V by C whole square 2.7 into 10 to the power 8 by the velocity of light is 3 into 10 to the power 8. This is the whole square root over. Clear? So it will be 2 into 1 minus this one, 1 minus. If you will solve this one, you will get 0.81 root over. And after solving, you will get 2 into 1 minus 0.81. It is 0.19 square root of this one. And it is equal to 2 into 0.436, which is equal to 0.872 meter. So this is the length of the rod in the rocket when the rocket is moving with a velocity of 2.7 into 10 to the 6 meter per second. Okay, so the length is contracted. Actual length was 2 meter and while moving in the rocket the length appears to be contracted and it is assumed to be 0.87. It appears to be 0.872 meter. Okay, so let us see another problem. Now the second question is that the apparent length of a rod in the direction of motion, moving with a velocity of 2 into 10 to the 8 meter per second is 1 meter. That means apparent length when it is in motion, that means L is 1 meter, not L0. L0, remember L0 is the length of the rod at rest. But what is the length of the rod at rest? You have to find out L0. That means see here what are given and what you have to find out. L0 you have to find out. And L is equal to 1 meter and V is equal to 2 into 10 to the power 8 meter per second. And your formula is L is equal to L0 into 1 minus V square by C square root over. And you have to find out L0. So L0 is equal to how much? L divided by this one. L divided by 1 minus V square by C square root over. This is your formula. L is equal to 1 meter. 1 by 1 minus V square by C square. That means V by C whole square. Your V is 2 into 10 to the power 8 and C is 3 into 10 to the power 8 whole square root over. Clear? And it is equal to 1 by, and if you will simplify this one, finally you will get here 10 to the 8, 10 to the cancel out, 2 by 3 whole square, that means 4 by 9, then 9 minus 4 divided by 9, and 9 will go to the numerator. Finally you will get 1.34 meter. This is your answer. Okay, and you should be thorough while solving. Okay, see here, your third problem is a spaceship is 50 meter long. A spaceship is 50 meter long on the ground. Clear? That means L0 is equal to 50 meter. When it is in flight, its length appears to be 49 meter to an observer on the ground. That means when it is in motion, its length appears to be 49 meter. That means L is equal to 49 meter. That means the length contracted. Clear? So what is the speed of the spaceship? That means what is the value of V? You have to find out V. So what is your formula? L is equal to L0 into 1 minus B square by C square root over. Clear? So L by L0 is equal to 1 minus B square by C square root over. Clear? And L by L0, here L is equal to how much? 49. 49 by 50 is equal to 1 minus B square by C square root over. And 49 by 50, it will be 0.98 is equal to 1 minus B square by C square root over. Clear? And squaring both the sides, we get 1 minus B square by C square is equal to 0.98 whole square, and which is equal to 0.9604 square of this one. So now minus B square by C square will go to the right hand side, and this term will go to the left hand side. So B square by C square is equal to 1 minus 0.9604, which is equal to 0.0396. So what is the value of V by C? That means take the square root of this one. So 0.0396 square root of this one, which is equal to, the value of this one is 0.199. Clear? Now V is equal to how much? 0.199 C. You can write like this, or you can put the value of light also. You will put the value of light, then you will get the answer. Okay, so that is the value of V. Clear? Let us see another question. See the question, the length of a spaceship when at rest on the ground measures 100 meter. That means what is given here? L0 is equal to 100 meter. Its length in flight as measured by an observer on the ground is 81 meter. That means L is equal to 81 meter. Length of the spaceship while in motion, that means 81 meter. Calculate the velocity with which the spaceship is moving. That means you have to find out V. Clear? We know L is equal to L0 into 1 minus B square by C square root over. So it implies L by L0 is equal to 1 minus B square by C square root over. Clear? And it implies L is equal to 81 by 100 is equal to 1 minus B square by C square root over. Clear? So 81 by 100 is 0.81. So it implies 1 minus B square by C square squaring is equal to 0.81 whole square. Clear? Is equal to 0.6561. Clear? So B square by C square is equal to 1 minus 0.6561, which is equal to 0.3439. Clear? So V by C square is equal to this one. So V is equal to square root of this one, and square root of this one is 0.3439 square root of this one into C. Clear? And now you can find out the value of this one, and 0.39 you can find out the value, and after that you will get the value of V. Okay. See here this question. The length of a rod is found to be half of its length when at rest. That means if the length of the rod at rest is L0, then L is equal to half of L0. This is given. The length of a rod is found to be half of its length when at rest. Half of the length when at rest. So what is the speed of the rod relative to the observer? That means you have to find out V. Okay. So that means L by L0, or we know L is equal to L0 into 1 minus V square by C square root over. So put the value of L. Half of L0 is equal to L0 into 1 minus V square by C square root over. Here L0 L0 cancel out. The remain 1 by 2 is equal to 1 minus V square by C square root over. So squaring both the sides, you will get 1 by 4 is equal to 1 minus V square by C square. So it will take V square by minus V square by C square to the left hand side. You get 1 minus 1 by 4, which is equal to 3 by 4. That means V by C is equal to root over of 3 by 4. That means root 3 by 2. So V is equal to root 3 by 2 into C. Okay, and now you can calculate the value. Then put the value of C, you will get the final result. Or simply root 3 by 2. Root 3 by 2 will be equal to how much? 0.866 C. This is your answer. Okay. And this is the most important question. And you have to do some extra work here. Calculate the percentage contraction of a rod moving with a velocity 0.8 times the velocity of light in a direction inclined at 60 degrees to its own length. That means it is moving not parallel to its length. But the formula which I have given you, or which you have read, it is along the length of the rod. The body moves along the parallel to the length of the rod, but it is given that it is 60 degree to its own length. Clear? So how to solve this one? First of all, the length L. That means see here. Here the length of the rod is like this. The rod is this one, and you have to split in two components. One is horizontal component and this is vertical component. Clear? And this angle is 60 degree to its own length. Clear? And it should be horizontal. So 60 degree to its own length. At rest, it is like this, horizontal, and while moving, it is moving in this direction. Clear? And now this one is L cos 60, this is L sin 60. Clear? So let this one is Lx, this one is Ly. So Lx is equal to L into cos 60 degree. It is equal to half L, because cos 60 is half, and Ly is equal to L sin 60 degree. Then L is equal, sin 60 is root 3 by 2, so root 3 by 2 L. Clear? But here the contraction appears only along Lx. There is no contraction along Ly. Clear? So there will be a decrease in the component Lx. There is no change in along Ly. Clear? So Lx dash is equal to Lx, because see here, this is Ly, this is also Ly, and this is Lx. So L is equal to Lx square plus Ly square root over. So you want to find out Ly and Lx. Clear? Here Ly dash is equal to Ly, but Lx dash is equal to Lx into 1 minus V square by C square root over. Clear? And Lx, here Lx is equal to half L. Lx equal to half L into 1 minus v square by c square, and it is given that 0.8 times. Clear? 0.8 times the velocity of light. V is moving how much? 0.8 times the velocity of light. Clear? The frame is moving parallel to the length of the rod, so the frame is moving along the in this direction. So V is equal to 0.8 c. So V by c, because the frame and the length of the rod will be in same direction. Here the frame is moving in this direction. Clear? So V is equal to 0.8 c. So V by c is equal to 0.8. So V by c whole square, that means 0.8 whole square, root over of this one. Clear? So if you will calculate this one, you will get 0.3 L. Okay, and therefore the length of the rod will be Lx square plus Ly square root over. Therefore L is equal to Lx dash square plus Ly dash square root over. It is equal to how much? Lx Ly, it was initial, and while in motion it will be Lx dash and Ly dash. It will be 0.3 L whole square plus root 3 by 2. Ly dash is equal to Ly L whole square root over this one, and after solving you will get 0.916 L. See here, it is given percentage contraction of the rod moving with a velocity 0.8 times the velocity of the light in a direction inclined at 60 degrees to its own length. Clear? So the rod is in the frame S dash, and the frame S dash is moving with a velocity v whose value is 0.8 c. Clear? And it is moving making an angle 60 degrees to the original length of the rod. So there will be contraction. And what is the percentage contraction of the rod? Okay, so this is the value of L dash, not L, it will be L dash. Length of the rod in moving frame, L dash. Length of the rod in moving frame, L dash. And L was the length of the rod at rest. And our question is that you have to find out the percentage contraction of the rod. So how to find out this one? So percentage contraction is equal to L minus original length is L, and moving is 0.916 L divided by original length is L into 100. Change in length by original length into 100. Change in length by original length into 100. So L cancel out. 1 minus 0.916, that means it will be 0.084 into 100. It is equal to 8.4%. Clear? It will be 8.4%. So the percentage contraction of the rod will be 8.4%. Clear? So this is all about your length contraction. In the next class I will tell you about time dilation. Okay, thank you.